to handle that situation, a method which is more suitable for, more suitable to be programmed will now be studied. That is the Quine-McCloskey's method. So one thing that you have already seen is that we have already motivated the Quine-McCloskey method, and you have already studied the method of Karnaugh maps. So what you have seen is that there are two important steps. The first step is what we call growing cubes, which basically involves joining adjacent cubes to form bigger cubes. Okay, and once you have got this, once you have grown,
CRM, are you sharing your desktop?
I will share. Yeah.
Okay. I thought just it is a problem.
Yeah. So we keep growing the cubes as far as possible, and a cube that cannot be grown anymore is called a prime cube, or it's also called a prime implicant. And finally, you have to take enough of these prime cubes so that all the mean terms in the onset are covered. Okay, so that is how it works. So now we'll see how the Quine-McCloskey method works. So I've just shared my desktop. I hope it is visible to you. Is it visible?
Yes, sir.
Okay. So yeah, so I mean, this is a summary. We'll come back to this later. So let us see what's happening.
Huh.
Yeah.
খাবার তো নেই না নিচে আছে
All right. Yeah, so the function that we have is shown over there. That is 0, 5, 8, 9, 10, 11, 14, 15. So we are just, I mean, for this example, we only have mean terms belonging to the onset. Okay, this is called the onset. Okay, so these are mean terms belonging to the onset. How many do you have? 4, 5, 6, 7, 8. You got 8 mean terms. Now, as I told you, this method is suitable, is designed so that it can be easily programmed. So now, what is the first step? The first step is to the first step is to join grow cubes to grow them. You want to join adjacent cubes. So, can anyone tell me when two cubes are adjacent? So when do you say that two cubes are adjacent? So what are these cubes? Cubes are simply product terms.
Sir, when the Hamming distance between them is 1.
Yes, that is true. That is true. But can you just say it in a slightly, so you can say that when they differ, yeah, what you have said is correct, but we say in slightly easier terms, we say that when they differ at one place only. At only one place. Okay, so that is when we say that. So now I think let us do it. So we are considering two cubes here. Okay, so this cube is 0. So what is the function? It's a function of. So let us try to. So the cube 0, that is. So what we are showing here is that this is the number of ones. So n ones and m is the number of don't cares. All right. So here you can see that number of ones is 0. Okay, all the bits in this mean term. So the mean term is a bar, b bar, c bar, d bar, right? So here, as you can see, the number of ones is 0. So any cube adjacent to this must have exactly one ones, right? So here we have 8. 8 is a, b bar, c bar, d bar, right? So we consider cubes with 0 number of ones, and then we consider cubes with 1 number of ones. So I mean, if you wish to find any cube adjacent to this one, any cube adjacent to this one, then that cube must have exactly 1 number of ones, right? Because this one has 0 number of ones. So in fact, 8 is one such. So if you join these, if you join these, what do you get? Oh, sorry. If you join this, what did you get? You would get b bar, c bar, d bar, right? So that is. I mean, this light green just shows that these two are adjacent, and when you join them, this is what you get: b bar, c bar, d bar. Okay, and that cube. So this is also a cube. All of these product terms are called cubes. So that cube can be shown this way. That is the cube. This is the result of joining the two cubes 0 and 8. Okay. So and over here you have, as you can see, you have got the number of ones is 0, okay, and you have got one don't care term. This is a don't care. This position is a don't care, right? So it can be either 0 or 1. In fact, that's what you have got. You have joined these two cubes. So this is a don't care, and you have got 0 number of ones. So here, I mean, you're just classifying the cubes. It helps you. So you can say that this is a bucket. This is a bucket. Okay, this is a bucket, indicating for cubes having 0 number of ones and 1 number of don't care positions. All right. So let us go on. Now, so we are done. You don't have, if you look at this, this is the only cube with 1 number of ones. Okay, so you can't have any more cubes adjacent to this cube. 0, all zeros. Okay, so now we move on. So you have got a cube with 1 number of ones. So if you want to find cubes that are adjacent to this. So you have already considered all zeros. So the next thing that we do is we consider cubes with 2 number of ones. Okay, as you can see, 2 number of ones. So those cubes are 5, 9, and 10. All right. So now you can see that you can see that 8 and 9 are adjacent. Okay, 8 and 9 are adjacent. So this one is A, B bar, C bar, D. So let us just write A, B bar, C bar, D. And if you combine them, so you can combine them, right? So what cube will you get if you combine them? A, B bar, C bar. All right. This is what you get when you combine these. All right. So we show that here. Now, as you can see, you can combine this with 10 also. You can combine this with 10 also. So if you combine this with 10, so that is, this cube is A, B bar, C, D bar. So this is A, B bar, C, D bar. And as you can see, we can combine this with 8 as well. So let me just write, this is 0, this is 8, this one is 5, this one is 9. Okay. I think I made a mistake.
So the
here.
5 should be 9.
Yeah. Yeah. I made a mistake here. This is, let me see. This is 9, yeah. So 5 is 0, 1, 0, 1. Yeah. And this is 1, 0, 1. Okay. Yeah, that's right. So I hope I've combined, so I must have made a mistake combining this also. So let me, so when I combine this, B will go out, right? So it will be A, C bar, sorry, 8, 8 again I made a mistake here. No, 8 is okay. So what happened? Oh, sorry, 5, what did I do? 8 and 9 are adjacent. I don't, 8 and 9 are adjacent. I made a mistake there. Sorry about that. 8 and 5 are not adjacent. 8 and 5 are not adjacent at all. 8 and 9 are adjacent. 0, 1, 0. Oh no, 1, 0, 0, 1. Yeah, so when I combine this, I have T is dropped. This is 9 and I am considering 10 now. Yeah, sorry about that. So I am considering 10 now, and when I combine these two, AB bar T bar. Okay. So this is what I get. This is so this, as you can see, is 0, 8, and this is 8, 9, and this is 8, 10. All right. So these are the cubes which are adjacent to 8, apart from the all 0 cube, which you have already handled earlier. Okay. So these are the cubes that you get. So now we progress further. So we consider cubes that are adjacent to 5, 9 and 10, because these are the cubes which have two number of ones, right? So these are the cubes with two number of ones, and then we consider cubes with three number of ones. So what if I find is that, well, we have this 5, let us write this somewhere. This is A bar, B, C bar, T. This is 5. We have not been able to combine it with anything. Now this is, we already got 9 here. So we find that 9, as you can see, 9 and 11 are adjacent. So we can write 11 somewhere. So 11 is 1011. All right. This is 11, and we can combine 9 and 11 as, so this is what you get when you combine 9 and 11. All right, you combine 9 and 11, this is what you get. And then you can also combine 10 and 11. So if you combine 10 and 11, you get, so these two are also adjacent. So you will get A, B bar, C. If you combine 10 and 11, right? Sorry, yeah, if you combine 10 and 11, this is what you get. A, B bar, C. All right. And you can also combine, you can combine 10 and 14. You can also combine 10 and 14. So we have to write down 14 somewhere. So let's write down 14 here. And what you can, so you can combine 10 and 14. So if you combine 10 and 14, what you get is A, C, D bar. So let us just see, this is have I written 11 correctly? Yeah, 14. So I'm combining, yeah, ACT bar. Okay. So this is 14 and this is 10. So if I combine 10 and 14, I just a minute. There we go. It's a minute. Just a minute, please. Yeah. Yeah, sorry about that interruption. Yeah. So what you saw is that you can combine 10 and 14 to get ACD bar. Okay. So ACD bar. So you get these cubes. All right. So now we got one more cube which is all ones. Okay, that is ABCD, and we can so ABCD is ABCD. So let us write that down here. ABC. This is all ones. So this one is adjacent to 11, as you can see. So we can write that down here. And when you combine these two, these differ in the second position, so that will get dropped. So A, C, D. Okay, A, C, D. Just and this is also adjacent. 14 is also adjacent. So ACD is 1115. We'll write 1115, and it's also adjacent to 14, and you get ABC. Okay, so ABC you can I think we'll write 08 here. It's too far off. This is adjacent to 14. So it's adjacent to 14 and it's ABC. Alright, so this is 1411, 1415. So if you compare this to the exercise that you have done, so we have basically finished everything at this level. So, you know, this is, if you consider the cube, so right over here you have F, which you are not considering, so this is at level 0, this is level 1, and so these are, and this is level 2, okay? So these are the mean terms. At level 1 you have got the atoms, okay? These are your mean terms, atoms, or you can say mean terms. And then you have got slightly bigger cubes, okay? Where you have dropped. So this is the, you know, the result of joining two mean terms, certain mean terms, which are adjacent. So what you find is that it's useful to circle this one. This one hasn't joined with anything, right? A bar, B, C bar, D. This one hasn't joined with anything. So, you know, of course, we'll now try to join some of these and get bigger cubes. But this one has been left behind. It hasn't joined with anything. So, we shall see. So in that sense, you can't really grow this cube anymore. Okay, this is a cube which you have not been able to grow because you haven't found any cube which is adjacent to this. So can't grow this cube anymore. So this one should be a prime cube or a prime implicant. All right. So now we'll try to repeat the exercise at this level. We have completed with this level, with level 1. So can you try with, so here also we are going to, we have this classification. So in level 1, in level 0, you have got 0 number of don't cares. If you remember, in level 0, you always had 0 number of don't cares. Sorry, in level 1, that is, this is level 0. In level 1, you had 0 number of don't cares. In level 2, you'll have cubes with 1 number of don't cares. All right. So these are all cubes with 1 don't care position. All right. So now you are combining cubes having one number of don't care, and um, and then you will consider those which have one number of ones and two number of ones. Well, you don't have any cube with zero number of ones here. No, you do have a cube with zero number of ones. So, okay, I don't know whether it has been missed out here, but we'll check out. So, do we have any cube? Yeah, so if you see 0, 8, 9, I might have missed that out here. So we should consider cubes with zero number of with zero number of ones and one number of ones. So if you look at this, you can combine. No, you can't combine. You can't combine these because well, you can't. So this is a cube with zero number of don't cares. And do you have any cube adjacent to this? So with one number of don't care, but the don't care has to be in the same position. So here A is the don't care term. So you can't combine this with any cube having an A. So all the cubes that you see here have an A. So you can't really combine this. So this one will also be, you can't combine this with anything else, right? So this one will also be another prime cube. Let us consider, so we are considering over here, we have got, these are the cubes with one number of don't cares and two number of don't cares. So what you find is that 8, 9 is adjacent to 10, 11. So let us see, 8, 9 and 10, 11. Yes, so these two have the don't care at position D, right? And they're adjacent. So you can combine these two, and what you will get is AB bar. All right. So you can combine this and this. So 8, 9, 10, 11. So 8, 9, 10, 11, you have combined 8, 9 with 10, 11 to get AB bar, right? And then you have well 8. So these two, now look at this, 8, 10, 9, 11. Okay. So 8, 10, 9, 11. Where is that? 8, 10 and 9, 11. The 8, 10, 9, 11, can you combine? Let us see. No, we are combining which one? 8, 8, 9, 10, 11. 8, 10 and 10, 11. Which one?
So 9, 11 should be A, B bar, D. You have written A, B bar, C.
Sorry? In 9,
7.
oh yeah, 9, 11, yes, A, B bar, D. Okay, I made a mistake here. So A, B bar, D. Yeah. So now, yeah, so you can combine 8, 10, 9, 11, right? Yeah. So this also gives you A, B bar, D. So you can see that, let us just show that these two, 8, 10, 9, 11, these are giving rise to the same cube. So this is a bit mechanical. So we are just combining. So you are getting the same result actually. Yeah. So yeah. So let us move on. I think that's all you get. So these are cubes with, yeah. So now you will combine cubes with 2 number of ones and 3 number of ones and 1 don't care. Okay. 1 don't care. So let us see what we get. This is the only one we get, it seems. Yeah, so this one will not combine, 911 will not combine with anything because here we don't have any cube with a don't care in this position. Here 1011 can combine with 1415. So we'll get AC when you combine 1011 with 1415. So where is 1415 is here and 1011 is here. So we can combine 1011 with 1415. And you will get AC. Okay. So 1011 with 1415. We combine to get AC, which is alright. And apparently we can combine one more. So which is 1014 and 1115, is it? Yeah, 10, 14 and 11, 15. So just 10, 14 and 11, 15. We still get AC here. So I think that's about it. Okay, so now so what you can see is that we can't grow anymore. So you can't grow this anymore. You can't grow this anymore. So which are the cubes which we haven't? So this cube, as you can see, we haven't been able to grow this cube. So these are the cubes which we couldn't grow, right? So we got these 5 cubes. Have I got it right? So 8, 9. I haven't put 8, 9 here. Have I used 8, 9 anywhere? Oh yeah, sorry. I've used this. So this one will not be in red. Or rather, let me do it like this. Yeah. So 8, 9 has been used. I've been able to grow 8, 9. Yeah, so let me just try it a little closer. I've been able to grow 8, 9. So these are the 4 cubes which cannot be grown anymore. All the other cubes have grown to something else. All right. So these are. So what you can see is that the cubes that have grown, I should use the cubes which have grown maximally, because just think about it. Should I try to? So ultimately, these are the cubes in my onset. All right. These are the cubes. This is my onset. Okay. So I have to cover all the cubes in my onset. Otherwise, my switching function will not work correctly. So now the question is, which of these should I retain? Do I need to retain this? No, because instead of this, I might as well retain this, because this covers this. Not only does it cover this, it also covers this. That means whenever this is true, this will also be true. All right. And whenever this is true, this will also be true. So I don't need to. So these are the cubes which you can say, the cubes that have been able to grow, I don't need to retain those. I only need to work with the cubes that I haven't been able to retain. All right. So now, so these are the prime implicants. All right. These are my prime implicants. Now, what you see is that this A bar, B bar, C bar, D bar, this one is covered only with B bar, C bar, D bar. Okay, that is shown over here. That is 0, 8. So you can, I mean, what you can see here, this is really summarized in this table. So it is better to, you should relate this table to this table. So what you can see is that, let us say 0, 8. 0, 8 is covering, so of course from the names it's evident which of these are been covered. So I've put a cross over there, and that's also, you know, so say 0, 8 is covering this one and this one. But this one, so all of these, this is your onset, okay? This is your onset. This is your onset. So all of these need to be covered. Now what you find is that 0, 8 or is the only, you know, prime cube or prime implicant to cover 0. So you don't have any, so you have to keep 0, 8, because if you don't keep 0, 8, 0 will not get this cube which is 0, this will not get covered. So this is an essential prime implicant. So this circled the prime implicants, so these are all prime implicants, and if the prime implicant has a circle in its row, then it's an essential prime implicant, because this prime implicant is the only prime implicant covering 0. All right. So this is an essential prime implicant. 5 is also a prime implicant, and this is the only prime implicant covering 5. So this is an essential prime implicant. All right. If you look at this, well, you got, this is the only prime implicant covering 14 and 15. So you have to keep this, because if you don't keep this, 14, 15 don't get covered. So you have to keep this. So this is also an essential prime implicant. And as you can see in this case, this one is the only prime implicant covering 9. So you have to keep this as well. So what you find is that All your prime implicants are essential prime implicants. So you have to keep all of them. So you can say that this switching function, which I think there's something wrong here. This is A V bar. This one will be not R but C. I don't know why I wrote R over there. So all of this will be, C bar. Okay. So this is your optimized switching function. You can't get anything smaller than this. All right. So what you have seen is that. So let us just summarize. Over here you have. So this is the first part where you try to grow your cubes as far as possible, and at some point you can't grow your cubes anymore. So you're left with prime cubes. So these are all your prime cubes. You can't grow these cubes anymore. All right. As you can see, you can't grow these cubes anymore. So these are your prime cubes, the cubes circled in red. All right. And you also find in this particular example that so the first thing you check is which of these cubes are prime, which of these prime cubes are essential. So in this particular example, you saw that all of them were essential. So any prime cube that is essential has to be retained. Okay. So in this case, it turns out that all these 4 prime cubes have to be retained. So this is your resulting, optimized switching function. So later on we'll see that it could happen that some of these prime cubes don't have to be retained. Okay, you could do with a subset of these prime cubes. So we'll see that tomorrow. Okay, not tomorrow, but rather on Wednesday. Okay, so we'll stop here now. Thank you. Any questions? Do you have?
Excuse me, sir.
Sorry?
Sir, I had posted. I've posted something on the chat. Could you please have a look? MS Teams chat.
Can you just?
Yes, sir. Sure. Sir, I just had a query. Like I had submitted my in-class assignment submission to Pavitra sir at his email ID. It was a few minutes later than the deadline, so WBCM wasn't accepting it. So will it be considered, sir?
No, this time we are actually, yeah, this was an in-class assignment, so we are only considering assignments that have been submitted within the deadline. Yeah.
All right, sir.
All right. Okay. All right, then we'll stop here. Yeah.